Good morning to everybody. For those of you in Europe, Middle East, good afternoon, good evening. I see some from India, Asia. Thank you for being awake. My name is Peter Blazer, and I'm going to be your host for today's webinar entitled Getting Started with Virtual Reactor 20. Before we launch into the webinar itself, we're going to get into the content in just a moment. A few quick logistics. This webinar will be recorded, so no need to be scribbling down notes. We're going to send an email afterwards with the playback, so you can pause it, take notes, watch it again at your convenience, share with others. So do be aware that's being recorded, will be coming soon. All our webinars are recorded and put on our website there at cpfd.software.com. If you click on the resources tab and then webinars, you'll find all our webinars available. We want this to be interactive, so please ask your questions. You don't need to wait till the end. In fact, we prefer if you don't. There is in the webinar panel a questions box. Go ahead and enter a question for the staff, hit send, that's going to come to us. We're going to compile those and get to as many of those at the end of this as we can. We are intentionally leaving time for Q&A. So please ask those questions as we go in the questions panel. There's a few on here that might not be very familiar with us. Now, this webinar is intended for users of Virtual Reactor, getting you started with a new version, but there's some that are maybe checking us out or just getting started with Virtual Reactor in the first place. So let me briefly introduce our company, CPFD Software. Here at CPFD Software, we're experts in fluid particle systems and simulations of those systems. Our product, Barracuda Virtual Reactor, simulates the hydrodynamics, the thermal behavior, and the chemical reactions, be those gas phase or particulate level, in fluidized systems. Really, the software is used to look inside large-scale industrial units, assessing performance through simulation, determining the root cause of underperformance, what's happening inside where you might not be able to see, reduce risk of changes through virtual testing, testing changes, design or operational on the computer instead of on your actual unit. And a side effect is you often identify additional optimization opportunities, and this is true whether the software is used on designing new systems or troubleshooting an existing unit. Virtual Reactor is deployed with software licensing and simulation services. So there's my introduction. We're glad you're here. With this, I'm about to turn it over here to Rosemary Clark. Rosemary is been with CPFD for over 5 years now. Time flies. She has performed service projects, used the software herself in an engineering capacity. She's a chemical engineer. She is an active member of our support team, hence the title. She is actively involved with the product, documentation, training materials, and generally an all-round customer advocate. So you'll be in good hands today. I'm gonna turn it over to Rosemary. Rosemary, are you on? Is your audio on? Are you ready?
Yeah, hello. Thanks for that introduction, Peter. Hey, I'm excited to introduce Barracuda Virtual Reactor version 20, which includes TechPlot for Barracuda, our new default post-processing tool for viewing and analyzing three-dimensional simulation results, as well as plotting XY data. The bulk of today's webinar will be dedicated to covering the basics of using TechPlot for Barracuda to perform common post-processing tasks. But before diving into that, let's look at a few other features and enhancements included with Virtual Reactor version 20. More details about these enhancements and features are included in the Virtual Reactor User's Manual, and I encourage everyone to take a look at the release guide chapter to learn all about the version 20 release. The first feature I'd like to talk about is version 20 support for RLM Cloud, which is an easy-to-use cloud-based solution for serving Reprise License Manager or RLM licenses. There are several reasons you might want to use RLM Cloud instead of or in addition to a traditional on-premise RLM server. One, it eliminates the need to configure and maintain an on-premise RLM server. which can reduce IT administrative tasks. And 2, it allows you to easily serve RLM licenses to cloud computing resources, such as machines running on AWS, Google Cloud, Azure, and others. And 3, it allows you to easily increase your license count. For example, if you need some short-term licenses to meet a project deadline. If you're interested in learning more about RLM Cloud or switching your current on-premise RLM license to RLM Cloud licenses, you can contact us and we'll be happy to help. So I'm going to drop out of PowerPoint now and bring up a Virtual Reactor version 20 GUI to demonstrate a few things. Related to RLM Cloud specifically, we built a new license manager interface to make it easy to point RLM client machines to both on-premise and RLM Cloud license servers. This is accessed in the Barracuda GUI by clicking on Help, Manage License Servers. And let's take a look at this dialog starting at the top of the Servers tab. The option to automatically unset any older style license environment variables needs to be selected in order for your TechPlot for Barracuda to access its license. In the List Manager section, you can point Barracuda to either an on-premise or a cloud-based RLM servers by clicking the Add button. If you want to point to an RLM Cloud server, you can click on Browse Files to select the license file provided to you by CPFD or your local distributor. Or if you want to point to an on-premise RLM server, click the Input Location button and specify the port and name or IP address of the server. In the dialog you see here, I've specified an on-premise server in the first row and then an RLM Cloud server in the second row. Mixing and matching RLM Cloud and on-premise license servers is fully supported. Barracuda will check out licenses from the specified servers in a top to bottom order, and you can change the order of the servers using the Move Up and Move Down buttons. The Log tab provides information each time a license is checked out, which allows you to verify which server is currently being used, and it helps if any debugging is necessary. The next few features I'm going to cover are enhancements to data output capabilities in Virtual Reactor. I'm using the Wednesday Gasifier training problem as our example simulation. So then if you like, you can follow along with the steps once the webinar recording is available. So let's take a look at FluxPlanes first. For anyone who's not familiar with FluxPlanes, these are high-frequency output files that allow you to track fluid and particle flow through specific planes in a Barracuda simulation. You can get detailed information about the composition of all materials flowing through FluxPlanes as well as raw particle data. FluxPlanes are extremely useful and many Barracuda users make extensive use of them. In version 20, we've improved the way that users specify the location of FluxPlanes within the simulation domain. When you click on the Select Plane button, you now get a reference grid dialog that allows you to click and drag to specify the position and size of each FluxPlane. You can grab the edges of the red rectangle to change the FluxPlane size. You can click and drag within the red rectangle to move the FluxPlane. And then when you click OK, the XYZ limits of the FluxPlane are filled into the text boxes based on the graphical region you defined. You can still type numbers directly into the text boxes if you know the exact position you want for the FluxPlane, or you can use the min and max keywords to refer to the minimum and maximum extents of the simulation domain. So next, we'll go to the data plane section of the GUI. This used to be called 2D plot data in previous versions of Barracuda. So I've brought up a version 17.4.1 GUI as well, just to remind you how this dialog used to look in case that's helpful. Data planes offer a way of getting relatively low frequency information from a simulation at points spaced evenly on a 2D plane within the domain. Barracuda users often use this kind of output to create plots of temperature versus height or fluid velocity versus radial position, for example. In version 20, Data Planes has a list manager style similar to other sections of the Barracuda GUI, and there's no limit to the number of data planes in any orientation. So if we open up the definition for a data plane, you can see that it can be located graphically using the click and drag with the mouse, very similar to flex planes, or by typing in the XYZ coordinates directly. A selection manager in the bottom half of the dialog allows you to select as many data output items as you want from the left side, and then bring them over to the selected data list on the right side. There are a few other options here in this dialog, but for the sake of time, I'm not going to cover them right now. But if you click on the Help button, it will bring up the data plane section of the user manual with full details. So exiting this data plane definition, a couple more things are worth mentioning. First, we've added a new text box where users can specify a string they want to use for the null cell output. This will make post-processing data plane information easier, allowing you to specifically exclude any null cells that are outside of your simulation domain. Secondly, we've improved the naming conventions for the data plane output files so that they're easier to find and identify in your project directory. All data plane output files begin with the word plane and then are named intuitively to help you quickly identify the variable contained in each file. One thing to note is that this improved naming convention is only applied to new projects created in version 20 by default. The reason for this is that if you define 2D data output in an older version of Barracuda, you probably already have post-processing scripts that refer to those files that use the older naming convention. So we didn't want to break those scripts if you bring your project up to version 20. So it is possible to switch to the new naming convention, and you can contact support if you want to do that. The last data output enhancement that I'll discuss here is data points. This used to be called transient data in previous versions of Barracuda. Again, I'll bring up a 1741 GUI to show what this used to look like. So data points are high-frequency data output entities located at specific points within the simulation. Barracuda users often place data points in locations where they have thermocouples or pressure taps in their physical systems in order to get the same kind of data from virtual reactor simulations. In the version 20 release, the data points interface has been reworked to use a consistent list manager style that you see throughout other sections of the Barracuda GUI. You can define as many data points as you like, and if we open up a data point definition, you'll see that we've added the ability to graphically select the point location using the Select Point button. This brings up a reference grid dialog that allows you to click and drag the red point to locate it within the simulation domain. When you click OK, the XYZ coordinates of the point are populated in the text boxes. You can type in XYZ values directly into these text boxes as well if you know exactly where you want your data point to be located. An available data, selected data interface, similar to the one we just saw in data planes, is used for data points as well. You can choose as many items from the left as you want and bring them over to the right for inclusion in the output file. All of these selected items will be output for the specific location in space. And you can reorder columns of data in the output file by using the up and down arrows. So that covers the data output enhancements for version 20. So let's turn to TechPlot for Barracuda, our new default post-processing tool. First, a few details that I want to mention regarding this bundled version of TechPlot 360. So one, your license to use Virtual Reactor 20 also includes a license of TechPlot for Barracuda at no additional charge. This allows you to post-process virtual reactor simulation results with TechPlot 360. Two, TechPlot for Barracuda uses the same RLM server as Virtual Reactor in order to check out a license. There is no license imposed limit on the number of instances of TechPlot for Barracuda you can open simultaneously. And 3, a full TechPlot 360 license, which is not included as part of TechPlot for Barracuda, is required to post-process simulation results from other products. And so please contact TechPlot directly if you would like to purchase a full TechPlot 360 license. Now, some of you may have watched our previous webinar presented in conjunction with TechPlot, which was called Getting Started with TechPlot for Barracuda. In that webinar, we looked at many things that TechPlot can do from a high level, including some advanced post-processing topics. But today's webinar will be different in that our goal is to show you step-by-step instructions for day-to-day post-processing tasks. We're going to go slower, narrate each click, and explain things as we go. We won't get into advanced topics, but rather we want to cover the basics in more detail. So the first thing I want to point out is one option in the visualization data output window. Here, you can specify the type of data output files that you want created. TechPlots are selected by default, but you can also select GMV files if you want to. And you can also convert GMV files from previously run simulation to TechPlot files and post-process those with TechPlot for Barracuda. And you can see the TechPlot for Barracuda section of the user manual for instructions on how to do that. So for our demonstration today, I started this simulation just before the webinar in order to have a few results files available, but the simulation is still currently running so that we can show you how to rescan for new results files. So to open TechPlot for Barracuda, you can use any of the buttons in the GUI for 2D or 3D visualization. So I'm going to click on the View Boundary Conditions in the Run window. And on the right-hand side of the screen, there is a quick macro panel with the shortcuts to all of the predefined views you might be familiar with from the Barracuda GUI. Double-click on the items to bring up the views such as Grid, CAD, Flex Planes, Data Points, Particles by Volume Fraction, and so on. You can manipulate your view by using buttons in the top toolbar. For example, there are several rotation methods available. You can choose one and then click and drag to rotate the model. You can right-click and drag to translate the model. And click and drag the center mouse button for zoom. Push away from yourself to zoom out and pull towards yourself to zoom in. And then you can right-click to exit any special mouse mode you're in and get back to the regular select mode. There's a set of snap to orientation view buttons that are quite nice for getting views at a specific angle. You can look straight onto the model in the 3 major directions or get back to the default angles by using the rightmost button. Within the TechPlot interface, many items can be selected by clicking and edited by right-clicking or double-clicking. You can also move items around within this frame by clicking and dragging, and then most items will show available options if you right-click on them. Barracuda simulations are transient, and you'll often need to move from one time step to another within the TechPlot interface. The solution time slider and controls allow you to do this very easily. You can drag the solution time slider to any currently loaded time, or you can use the control buttons to play through time, step forward or backward one solution time, or go to the beginning or end time steps. So if I go to the end time step here, you can see that we're out 2.2 seconds. Since the simulation has been running in the background, we can now rescan to load any new output files that have been created by Barracuda since we opened this TechPlot GUI. To do this, click on File, Load Barracuda Data, and click on the Rescan All Data button. Okay, then click on the Go to End Time Step button, and now we can notice that the time is 2.4 seconds. So creating an animation of the current view is done using the Details button. Click it to open the Time Animation Details dialog. TechPlot gives you a lot of options here, including the start and end time for the animation, as well as the ability to skip steps. Click the movie reel icon to open the export dialog. Here you can choose from many different output formats, including video and image sequence formats. In this dialog, you can also adjust a number of other things, including the animation speed for the output video file. Okay, next, let's look at adjusting the color bar. Double-clicking the color bar brings up the contour and multicoloring details box. There are many things that you can adjust within this box, so I encourage you all to explore it on your own as you start using TechPlot. TechPlot also has great documentation built in, so you can always click the Help button to get full details on all available options. For today, I'll focus on just a few of the most basic things that Barracuda users will want to use on a day-to-day basis. First, notice the drop-down box on the top left of the dialog. This shows the currently selected variable by which your cells or particles are being colored. You can select different variables by using the drop-down and clicking on the variable name. Note that all the possible variables are shown in the list, so you need to select the appropriate cell or particle variables based on the context of what you're doing. For this example, though, we'll stick with particle volume fraction. So next, let's click on the Levels and Color tab. A common task when post-processing is adjusting the numerical limits of the color bar. This lets you to zoom in on specific ranges of data and highlight important details of the simulation results. Use the Set Levels button to bring up the Enter Contour Levels dialog. We've found that the Min, Max, and Delta option is very nice. Here, let's set the Min to 0 and leave the Max at 0.6 and set our Delta to 0.1. When we click OK, you can see that the numbers on the color bar have been adjusted accordingly. Another nice feature of TechPlot is that it has a very large selection of built-in color maps. You can click the drop-down menu to see all of the available options. So if you feel nostalgic about GMV, you can always choose Small Rainbow and you'll feel right at home. It's also very easy to reverse your color map by checking the reverse box. The next topic I'd like to cover is blanking. In TechPlot, the concept of blanking allows you to hide specific cells and/or particles based on a user-defined criteria. You can go to the Plot menu and choose Blanking, Value Blanking. And let's start with the particle phase. In the Wednesday gasifier, we have 2 particle species in the fluidized bed. Species 1 is our initial bed, and species 2 is fresh coal that is fed in at the side of the vessel. So let's blank species 1 so that we only see species 2. First, check the box for Include Value Blanking. Then we'll set our criteria to blank when the species index is equal to 1. When we click the checkbox for active, we can see that this blanking criteria has been applied because the initial bed particles are no longer visible. Blanking can also be used to show spatial subsets of the system by hiding cells. Our particle blanking definition used constraint number 1, and you can see that up to 8 constraints can be defined at the same time. Let's use constraint number 2 to blank when y is greater than 0. When we make this blanking criteria active, we can see that both cells and particles that meet the criteria are hidden from view. So next, I want to introduce the Zone Style dialog. Click the Zone Style button to bring up this window. Almost every aspect of the view shown in TechPlot can be adjusted in this dialog, and you can see that there are many tabs, rows, columns, and settings available to let you work with your view. For now, I'd like to point something specifically related to particle blanking. When we blink particles, it is often the case that the remaining particles on screen are a little difficult to see clearly. The default view for the particles is a single pixel, which works well for full beds of particles, but can be tough when you're looking at just a small number of particles. So you can right-click the symbol shape column in the particles row and choose sphere. Right-click the scatter size and choose 1%. We can now see the particles much more clearly. The rendering time for spheres is longer than for single pixels, but in cases like this, it's still very fast, and then it helps us to see our data more clearly. Another view option that Barracuda users will often want to adjust is the transparency or translucency of the vessel on screen. If we right-click on the cells shown on screen, we can select different levels of translucency or disable the translucency completely. By clicking the main translucency button, we can get a view that looks like we've cut a solid vessel in half and are looking inside of it. Clicking the same again re-enables the translucency so that we get back to the original semi-transparent view. So next, let's touch on the idea of frames in TechPlot and the ability to tile them so that you can see multiple views of your simulation results in the same window. Click the outside edge of your frame to bring up the black handles. Use Control-C to copy and Control-V to paste. Then go to Frame, Tile Frames, and choose the vertical tiling option. This will arrange our two frames side by side, and then we can start to adjust either frame individually. In our new frame, let's disable that blinking that we had previously defined. Go to Plot, Blinking, Value Blinking, and uncheck the Include Value Blinking option. I'd like to show how to use slices in TechPlot. So let's get our transparent model view by double-clicking the Quick Macro Panel item for that. Next, click the Slices box on the left panel. You'll see the default central slice come up in our current view. There's a nice interactive slicing tool that you can activate by clicking the small icon next to Slices or on the top toolbar. Let's do that, and then we can click and drag the slice to a new position very easily. You can access more options for slices by clicking the Details button. One very nice feature about slices is the ability to turn on the mesh. Let's switch to a Z-slice to illustrate this point. Go to the Other tab and check the box for Show Mesh. If we rotate our view and then zoom in a little more, you can see how showing the mesh and moving the slice with the interactive slicing tool can be very helpful and convenient for inspecting the grid in models that have complex internal geometries. Let's disable the mesh for now and go back to the Definition tab to look at a few more important options. You can use the Slice Location dropdown to change between X, Y, and Z or other orientations, just like we did to do the mesh slice. So let's keep it on Z-plane option for now, and we can disable the primary slice and then check the box for Show Start End Slices. Let's also check the box for Show Intermediate Slices and specify that we want 10 slices. As you can see, it's very easy and quick to create many evenly spaced slices, which is often a great way of communicating your three-dimensional simulation results. So let's change the variable that we're using to color the slices by. Double-click the color bar and use the drop-down menu to choose a different variable. Instead of I, let's choose mole fraction of methane. You can see that the slices have changed and are now showing this different variable. Finally, let's disable the start and end slices and re-enable that primary slice. Then go to the Animate tab, which allows you to animate the slice in a number of different ways. For example, you can limit the animation speed to 10 frames per second and then play the animation. This animation can also be exported to a video file in the same way as our transient solution time animation discussed earlier. So that covers the items that we wanted to highlight for post-processing three-dimensional simulation results. So let's turn our attention to plotting XY data now. Virtual Reactor outputs a number of data files that contain columns of simulation output information, and TechPlot for Barracuda can be used to make XY plots of this data. So let's create a new page using the Pages tab. Click Add, and then let's name our page for easy identification. We'll call it XY Plots for now. And you can see that we have a blank frame at first, and we need to load our XY data into TechPlot. You go to File, Load Barracuda Data, and choose Load Data File. For this example, let's choose our flux plane that we defined to measure early particle entrainment. Browse for the file and click Open. By default, TechPlot will show column 1 versus column 2, but it has actually loaded all the data from the file into memory. We can choose a different column of data to plot by double-clicking the line. This brings up the mapping style dialog, which is similar to the zone style dialog we used earlier for 3D data. TechPlot reads in all of the column header information from the data file, and the map name column shows us the data available for plotting. We can check or uncheck boxes in the Show Map column to choose what is plotted in the current frame. So let's select fluid mass flow rate and particle mass flow rate for this example. Click in the plot frame and then press Ctrl F to auto scale the axes of the plot so that all currently plotted data is visible. You can change the axis titles by double clicking. For the y-axis, let's choose the used text option and set the label to mass flow rate in kilograms per second. When we click close, the new axis label is shown. You can also add a legend to the plot by choosing Plot, Line Legend. Check the box for Show Line Legend and then close the dialog. TechPlot uses the map names from the Map Styles dialog, so let's open that again and adjust the legend labels. Let's change the map name for row 1 to Fluid by double-clicking and then entering our desired text. And then let's change the map name for row 5 to Particles. You can see that the legend text has been changed, and we can drag the legend to a new position within the frame. You can have multiple XY plot frames on your page, similar to what we showed for frames of 3D views. These can be tiled in the same way so that you can arrange many XY plots on a single page. Using Control-C and Control-V, we can create many frames, and then going to Frame, Tile Frames, we can create a grid of plot frames. Then each plot can be edited individually to create several different plots from the same data file. You can also have some frames showing XY data and then other frames showing 3D data all at the same time. The last thing that we want to cover today is the concept of using layout files in TechPlot. Once you have pages, frames, and views that you want to keep, you should save a layout file. This is similar to the concept of attribute files that you may have used in the past when post-processing with GMV. Click File, Save Layout, and enter a name for the layout file. In this example, we'll save it as My Layout. If we close TechPlot at this point and then relaunch it from the Barracuda GUI, we can get back to the same view again very easily. Use the File, Load Barracuda Data tool and choose Load Layout. Then we can select the layout that we just saved, and then you'll get back to the pages, frames, and views that you previously defined. So that's everything that we wanted to cover today. I'd like to point out that there are a number of resources available on using TechPlot for Barracuda. We've recorded a number of training videos specifically for post-processing virtual reactor results, and those are available on the CPFD support site. And TechPlot also has a large collection of TechPlot 360 training videos available on their site, which are not Barracuda specific, but they can be very, very helpful. Finally, detailed documentation is included with the installation of TechPlot for Barracuda, and you can access all of that information from within the TechPlot GUI. I'll hand it back over to Peter now and then answer any questions that people may have asked during the presentation. Sam Clark, the Barracuda Product Manager, is also here on the line, and he can help with any questions as needed as well.
Thanks, Rosemary. And we are going to get to those questions very soon. Before we do, just a few more logistical things. As I was watching this, I'm thinking, I need training. How's that for a segue? We've had a lot of questions about training on Virtual Reactor 20, and training classes are designed for people who are new to the software. We have transitioned to a web-based training tool, so this combines the lecture component, where we demonstrate project setup, post-processing analysis, the group discussion, all the things you'd get in a class, but we've managed to retain the one-on-one aspect of that, where one thing that sets our trainings apart is that attendees are able to set up their first project with our support during private breakout sessions. And so that's how we're doing it. We've managed to do that web-based and retain that one-on-one aspect. And it's not just a concept. We've done this. We have feedback there on that link to a LinkedIn video where one of the attendees of the prior class talked about his experience. So you can play that. We will send, once again, links to all this information in an email after this. So we do have web-based training coming up. These are offered in both public and private forums. Our next class is a public class the week after next, beginning July 20th, and we are scheduling future classes after that as well. As I mentioned, training is typically intended for people new to the software, just getting started, but if you are a current user and say, wow, Virtual Reactor 20 seems a lot more powerful, there's new features in TechPlot for Barracuda, I could like to sit in on some of this, talk to us. It makes sense to sit in on parts of the class for that as well. So if you're looking for how to take a next step, consider training. As I mentioned, playback is going to be available soon. This webinar is being recorded, and we will send a link with that. And for those of you that want to know more about how to work with us, please know that Barracuda Virtual Reactor, the simulation technology, is available through both software licensing and simulation services. We offer training and actually a whole lot more. We have expertise in all kinds of fluid particle systems and processes. And whether it's application support, consulting, direct through us or through many of our global research academic partners, contact us to talk about how to get started. With that, we've had a few questions come in. Please keep them coming. And we are going to transition now to sort of a Q&A session. So Rosemary, are you ready?
Yes. Yeah.
You're in no effect.
Unmute button.
We're all working remote.
Yes.
So okay, here's the first one. Can TechPlot for Barracuda be used to post-process data produced by older versions?
Yes. Yeah. You would need to convert your GMV files to TechPlot files. And in the TechPlot for Barracuda section of the user manual, it goes over using, it's called, I believe, GMV to PLT, and it will explain how you can go about doing that, using that script in your directory. And it comes with version 20.
Okay, great. This next one's about flux planes.
Okay.
And the user is asking, can the flux planes be only oriented in the X, Y, Z positions, or can they be placed on an angle in a combination of the coordinates?
So in Barracuda, you can only orient your flux planes in X, Y, and Z. But if you want to use a slice in TechPlot, those can be in any orientation. They do not have to be just X, Y, Z. I believe you can use some points to create a plane, a slice rather, in any orientation. So not in Barracuda. Barracuda ones, they have to be in the X, Y, Z positions, but TechPlot, you have a little bit more flexibility for post-processing.
Okay. And there's two types of flux planes. There's interior planes and then those at boundaries. And those that are placed at boundary conditions do conform to the boundary. Is that correct?
Yes.
Okay. And then I would just encourage this user, there may be workarounds on some of that. If you do need flux planes at an angle, while the feature itself natively isn't there, I have used a series of planes to kind of stair step angles before for a project. So if there is something that you're not able to get your data out, please contact our support team. We'll be happy to brainstorm with you and talk through ways to get the data you're looking for. Yeah. Okay, this next question, how big are TechPlot files compared with GMV files?
They're very comparable in size. So I think running a simulation in version 20, you're not going to see a big difference using TechPlot files, just TechPlot files. Now, if you click the option to include both GMV and TechPlot files, then your simulation directories are going to get about twice as big. So you just need to be very aware of that and your constraints on size in your Barracuda machine.
Okay. When I use frames, can I compare multiple cases? I think this one's asking about not different views of the same simulation, but comparing a before and after, for example, different operating conditions, different designs.
Yeah, you can do that as well. You would create a new frame and then pull the Barracuda data from a different simulation directory. And I believe that was covered in our last webinar. And if it is not, we will make a training video of that and put it on the support site with the other TechPlot for Barracuda training videos, because that is a very nice feature. You can easily compare two cases without having to use multi-frame or scripting to create your animations. So it is a very nice feature.
Great. And this one, I think, is closely related. It just came in, but it says it appears that graphics can be exported as pictures and videos that can easily be imported into other applications. Is this correct? And I'm guessing this is someone who's used our software before when it was not so straightforward, but for those that are wondering, please clarify, Rosemary.
Yeah, you can create images very easily, and they can be exported as PNGs and JPEGs and a number of other types. And then also the images, the animations can be easily exported, and you can also use export to a sequence of images. So you can have sequences of images that then you can make into an animation in a separate way if you're more comfortable with that. But yeah, it's very easy to create animations. You don't have to use scripting, so it's very nice.
There's a couple follow-ups that just came here, probably based on this flux plane discussion. So let me try and combine a couple of them. So can we create flux planes of different shapes is one, and another one says, can we create a flux plane in a radial direction, so not square, rectangular? Different users, but same type of question.
Okay. I think for this question, I might ask Sam Clark, because I believe he might be able to answer that question a little better than I can. Go.
Yeah, sure, no problem. So, currently in Barracuda, all of the flux planes are strictly rectangular shapes. You specify X min, X max, Y min, Y max, and a Z position, for example. And then the flux plane has to be a rectangular shape. I mean, it's cut by the geometry of the system, but otherwise you cannot currently make an arbitrarily shaped flux plane. It sounds like people are really interested in this, though, so I'm definitely making a note here on the fact that this is an important feature that would be useful for Barracuda users. So yeah, we'll definitely take a look at that, because it sounds like this must be a useful thing that people are interested in doing.
Thanks, Sam. And again, for everyone's benefit, that's Sam Clark, product manager for Barracuda Virtual Reactor. One thought, Sam, I'm just going to interject here. We're focusing a lot on flux planes in this discussion, and this is what I love the interactive part, because the questions keep more questions coming. But flux data is available not just through the plane. Now, that's obviously the high frequency data, but to instantaneous and average flux is written out at the plot interval. And in TechPlot for Barracuda, slices can be at different orientations, and also and I'm thinking out loud here, so help me out, but I think also then we could create a selection based on some variable, radius, for example, where if you're looking for radial slices, you could probably process the data in TechPlot for Barracuda. Does that sound right? You'd probably know more than me.
Yeah, I think so, Peter. And I think especially for things like that, where if you can define a well-defined function, such as radial position or something like that, then you can definitely do that in TechPlot for Barracuda. Really strange shapes that don't fall into a nice form might be a little trickier. But yeah, otherwise the capabilities in TechPlot could make that sort of extraction possible. And like you said, it depends on exactly what you're going for. If you need really, really high frequency output data, then that's not as useful to do through the TechPlot interface, just because of the file sizes for those fully three-dimensional output files. But yeah, if you need low frequency information or time average information, then yeah, that could certainly be a good approach for that problem.
Thanks, Sam. Okay, looking over here, actually, before I get to the next question, let me just comment, we want to help you. So if you're not able to get some data out for whatever reason, please contact our support team. We are here to help. Okay, going to this next question. When we have several volumes or parts inside a geometry, is it possible to isolate one volume and observe the CFD results inside this volume?
Well, I guess it kind of depends on if you just want to isolate one volume in your post-processing. You can definitely do that by using a spatial subset and zooming in, or just observing one particular part of your system. But in regards to running it in Barracuda, I'm not exactly sure. What do you think, Sam?
Okay, yeah. So I mean, in general, the Barracuda domain is just defined by your STL file. So as long as the STL file can fully describe the different volumes that you're interested in, I think you're fine there. And then a lot of times people do use flux planes, say underneath a certain elevation or above a certain elevation, so that you can isolate the flow rates through a specific region of space. So yeah, I would say probably, from a post-processing point of view, usually it's possible to isolate exactly a certain volume that you're interested in.
And I think just like the last question, the answer is gonna depend a bit on the system. Certainly if you have a closed circulating loop, it's easy to spatially identify different locations, or if you have a stripper on top of a standpipe, for example, those are more straightforward. If it's something inside of something else and they're still coupled, that might be a little more challenging. So please, if we did not answer your question in this discussion, please reach out to us. Okay, let me scan through here. When is the next training? So I mentioned we have a training the week after next, July 20th through 23rd, web-based training. That's a public class and spaces are still available, so contact us for that. I suspect this question means the next one after that. And I've actually talked to 3 different organizations now that would like training, but that particular week does not work. So we are looking to schedule another class for these companies. So far, I'm hearing late August, early September. Sounds right. But if you have interest in training but cannot make the July class, contact us. Let me know what might work for you, and I'll get with the support and training team and see if we can't put a class together at a convenient time. One more question here. Okay, support. Encourage people to contact support. Who do I contact for support with TechPlot for Barracuda? So I think this is specifically on the TechPlot for Barracuda.
Yeah, so if you're using TechPlot for Barracuda and you have some questions on how to do something or yeah, just anything, you can first contact us at CPFD through the support email, and we can answer your questions or we can figure out how to do things. And then if we can't figure it out, then that's when we will go to TechPlot support and ask them to help us, and then communicate it with you or make a video and put it on our support site so like other people can see it as well. And so, yeah, so that would we would be your first line of support.
And I'll just give a quick shout out to the team at TechPlot here. They have been fantastic in their support of Barracuda Virtual Reactor users. So do come to us first. If we didn't know, we go to them, and they've really helped us enable things that were beyond what either of us had thought. So working together has been fantastic. Well, hey, if I, for some reason, skipped over your question, because there's a number on the screen here, we will review these and get back to you afterwards. I want to thank everybody for taking time out of your busy schedules. And again, for a lot of you, this is in the evening or even overnight. So we're grateful that you have joined us. And if we missed anything, please contact us. Let us know how we can help. Thank you so much. Have a good rest of your day. This concludes the webinar.